Monday morning! I am MPJ, and this is FunFunFunction. This is a series where we learn Haskell together. I don't know Haskell. We are learning it from the book Learn You a Haskell. There's a link to it in the description below. If you just stumble across this video, you might want to watch the episodes from the beginning by clicking there. In this episode, we will be looking at a segment of the book called Baby's First Functions. Link in the episode description. This segment of the Learn You a Haskell book talks about defining functions. And this is how you do it. Double me x equals x plus x. Now we have a function and I can call double me 5 and that will give us 10. We're learning! Somebody in the comments complained about me using a lot of paper in my episodes, so in honor of that person I bought these huge ass papers and these huge pens. Anyway, you have the function name here, and this is the parameter, and this is the function body. I'm going to copy this, and bam, I just saved that as a file called baby.hs, and according to the book, this is how you load it. So it's like :L and then baby. We are not gonna do that because that's insane. I want to write out load. Okay, compiling main, baby.hs interpreted, and okay, modules loaded main. What? Why main? I didn't define main anywhere. Maybe that's some default mod. If you know that, write down in the comments. Either way, I think we can now call the function. Yes, I get IntelliSense with tab. That's pretty cool. So I can call double me 6 and I get 12. Does that work with floating point numbers? Yes, it does. So next up, the book wants us to do a function called double us, and it's gonna take 2 arguments, x and y equals x times 2 plus y times 2. And the book does that, but I want spaces. I will load baby again and we'll call double us 3 7. That's 20. Maybe. Okay, yeah, we'll trust Haskell. Not unsurprisingly, you can call your own functions inside of other functions. So I can go double me x and double I can't type double me, and I can remove that. So you see that I'm now referring here and here. So this is the same thing. I'm blowing your mind here. But joking aside, this is a pretty good example of a pattern that you will be seeing used a lot in Haskell. Combining functions. More specifically, making basic functions that are obviously correct and combining them into more complex functions. And we do this in order to avoid repetition. This is not a new concept, all programming languages have it, but because Haskell is so crazy terse, just look at this. It becomes sort of supercharged in Haskell. Just to give you an idea about how little syntax it requires in Haskell to define a function, I'm just going to go and implement this quickly in Java. So I'm just going to write public class, because everything in Java needs to be a class. My math utils. And I also like public static void. No, it's gonna be an int. My double me, and it's gonna take an int, and it's gonna take x, and it's gonna be wham, and it's going to return x plus x. So look at this. This is, I'm gonna pull this up for a bit so you see it. This is 88 characters, and this is, say what, 18 characters. So Java syntax is 480% of Haskell syntax. And remember that both of these are statically typed languages. In JavaScript, this would be double me x uh, x plus x, and you would have to say const as well, or possibly var to be nice. If I had said that, yeah, these, like, look how much shorter JavaScript is than Java, you could have said that there's all kinds of typing information here that adds safety. But in the Haskell case, Haskell actually has a strong static type system, just like Java does. The difference is that Haskell infers these things for us, so we don't have to declare them explicitly like we have to do in Java. And yes, Java people, I know that this comparison has several problems, but I do it to make the point that Haskell has a very low function overhead. What I mean by that is that it is a lot cheaper to create a function in Haskell compared to most other languages. Related to this, I want to mention another episode I made on arrow functions in JavaScript, because I think that there is a lot of Haskell in the arrow functions in JavaScript. You can check out that episode by clicking there. But we're doing Haskell here, so let's delete this Java and JavaScript, and we're back to Haskell. By the way, it doesn't matter which order you define these functions. So I can take this here, and I can move it up here, and I can load baby again, and I can call double us 7. What does this error even mean? Interactive 9.1 error. No instance for show A0 arrow A0 arising from the use of print. Maybe you haven't applied a function to enough arguments. Oh, wait a minute. Oh, it was actually helpful. 7, 8, 30. I just called it with 7 here, and I needed to call it with 7 and 8 because, well, it has 2 arguments. But the point that I was going to make was that even though we define double us here, we can refer to double me in this function here, even though that is defined on line 2. Now we're gonna take a look at if then else. So we're gonna write a function called double small number, which is going to, if the number that we give it is smaller than 100, it's going to double it. Very useful. So it's gonna take the number, the argument x, the number x, and if x is over 100, it's just going to then just going to return x. Else, it's going to be x times 2. Let's load that. Load baby. And we're gonna call double small number, and we are going to say 101. It's going to return 101 because that's not a small number. But if we call double small number with, say, 7, it's going to double it. So you've seen an if else before, but a subtle thing in Haskell is that else is mandatory. It simply must return something. There's no null. In JavaScript, for instance, you could just omit the else. So I could do a function double small number in JavaScript, and I would like, if the number x is below 100, I could return x times 2. And if it wasn't 2 here, it would just go to the next line and it would return undefined, which might be a nasty surprise for the person using the function double small number. So if JavaScript was Haskell, the compiler would have forced you to do something like this. I'm going to delete this JavaScript code. By the way, you could write this on one line, just to show you that that is perfectly possible. Double small number 714 still works, but dividing into multiple lines it's I don't know, I think it's pretty nice. The book talks about the fact that this is an expression. So what's an expression? Let's see, expression examples. So an expression is simply a piece of code that returns a value. So 5 is an expression that returns a value. 4 plus 8, that's an expression. X plus y, that's also an expression. And now, this is also an expression, because this will always return a value. That's why you need the else, because if it didn't have the else, this would not really be an expression. It would not always return a value. This is also where parens come in. Let's say that we wanted to add 1 to the value that we doubled. Let's load that. Oops, I have a parse error because, yeah, this is not valid Haskell. Let's delete all that. Let's load it again. All right, and I call double small number 6. That's 13. It doubles it and then it adds 1. But if I call double small number 101, we expect this to be 102, or we want this to be 102, but it's still 101 because it's actually evaluating like this, right? If x is 100, it's going to return x, or else it's going to return x times 2 plus 1. So if you wanted to add the 1 either way, we need to add parens here, and that is what makes this a single expression. We use the parens to denote that this is an expression. In the book, they suggest adding this to the function name. This is a bit funky to me. I'm just gonna load that, and then you call double small number and 5. This is not a special character in Haskell. It's a completely valid thing to have in a function name. But the way I understand it is that you tend to add these when you have a function that is a slightly modified version of something. So in this case, I guess that we add it because, you know, it's doubling the small number, kind of, almost-ish. I don't quite understand the need for this convention yet. If you have an insight on this, please comment down below. But either way, these are, like, you could do Conan O'Brien, and it's me, Conan O'Brien. And that should work. Conan O'Brien. It should be noted here that we cannot do this, I think. So if I do load that, I get some weird error. Data constructor Conan O'Brien not in scope. So functions cannot begin with a capital letter. The book says that it will talk about why later, and I guess that it will have to do with these data constructors, maybe. And we should also look at the fact that this doesn't take any function parameters. So this is a function that is just this expression. This is a function that will always return this string, it's a me, Conan O'Brien. To the JavaScript part of my brain, this looks a lot like a variable, or I guess a constant, because it's not possible to redefine it. So I assume that in Haskell, maybe you don't use constants at all. You just use this, functions that are defined to values. In Haskell, functions like this, functions that don't take any parameters, they are referred to as definitions, or sometimes you just call them names. The Ruby part of my brain, it kind of draws a parallel to symbols. Not sure if that's correct. That is the end of us reading or learning the Baby's First Functions segment of the book Learn You a Haskell. If you want to try this on your own, there's a link in the description to this exact segment of the Learn You a Haskell book. Next time we will be looking at lists. Do not miss that. You have just watched an episode of FunFunFunction. I release these every Monday morning. If you like this episode, you should click the channel below and check out if there are other episodes that you like, and there will be, and so you should subscribe. I am MPJ. Until next Monday morning, stay tuned.